All right, good afternoon and welcome to today's webinar, which is a thought leadership panel discussion on the scalability of metal additive manufacturing. The webinar is presented by Xerox and hosted by 3D Metal Printing Magazine. I'm Brad Kuvan, I'm the editorial director at 3D Metal Printing and Precision Metal Forming Association, and I'm pleased to serve as your moderator today. Before we get started, just a few notes about the meeting. It's being recorded for archiving, and the archived event will be posted to the 3D Metal Printing website within the next few days. We'll let you know via email when that webinar is available for viewing online. Also, all participants in the meeting are in listen-only mode. That means that the speakers, listeners, will not be able to hear any audio from your site during the program. However, you can communicate with us throughout the program by submitting any questions or comments using the question box, which is located on that right-hand control panel on your go-to screen. You'll simply type your question to an organizer as selected from the drop-down menu. And then at the end of the panel discussion, you'll have the option to use that same question panel to pose questions to our panelists. So now it's time to begin the webinar. We're going to discuss a variety of topics with our panel related to scalability. Among those topics is the role that scalability will play or can play in ensuring supply chain resiliency. We'll talk about applications where metal additive manufacturing already is exhibiting scalability, and then the hurdles to achieving scalability with other areas of manufacturing and the strategies for overcoming those hurdles. And then we'll talk about scalability in relationship to some specific AM processes. So joining us on the panel this afternoon is Tim Bell. Tim is the head of the U.S. Center of Competence for AM at Siemens Digital Industries. He's spent more than 25 or 35 years in manufacturing. He spent 20 years as a machinist, a programmer, designer, and entrepreneur of small contract manufacturing companies. And for the last 15 years or so, Tim's focused on AM of components and assemblies supporting the aerospace, defense, and medical industries. Stacy Del Vecchio is president of Stacy D Consulting, focused on the business of AM. She's a technical advisor with the Society of Manufacturing Engineers Additive Manufacturing Technical Community and has been industry peer review panelist for Oak Ridge National Labs manufacturing facility development. Before launching Stacy D Consulting, she was the AM product manager at Caterpillar. And earlier this year, Stacy edited her first book, Women in 3D Printing, From Bones to Bridges and Everything in Between. Matthias Schmidt-Lehr is co-founder and managing partner of the management consultancy AM Power in Hamburg, Germany. Matthias has been a professional user of additive manufacturing since 2014, including working at Laser Zentrum Nord as a team leader and key account manager for polymer additive manufacturing. In 2017, he helped to found AM Power, a leading consulting company in the field of additive manufacturing, supporting companies in making strategic decisions, including establishing quality management systems. And last but not least, Bender Kutub is a product manager at Xerox, where he leads the company's 3D printing hardware group. His current focus is on delivering an accessible metal AM solution that addresses the need for fast, cost-effective, reliable spare parts and how to provide the solution anywhere globally. Before joining Xerox, Bender led the development of product solutions to enable the qualification of polymer 3D printed parts for flight applications and led the creation of simulation solutions to reduce the barriers to adoption of AM for production applications. All right, so let's get started. First things first, now that you know all about our distinguished panel, we want to learn a little bit about you, our audience. So we've got a brief survey of 4 multiple choice questions. We'll ask you to take a couple seconds to answer each question and we'll show the results. So please, let's take a look at the first question, talking about your AM experience level. See there, 57% have used 3D printing. Only 4% have never, so that's interesting. Okay, we can go to the next question, please. What we got for answer? Of course, laser thought of that. A lot of others. I wonder what those are. A lot of jetting. That's good. Okay. All right. Show the next question. What do we expect to see here? Mostly product development, maybe? Low volume production?
That's what I'm guessing.
Yep. Wow, okay, a lot of R&D. Okay. So lots of probably more than one answers. Not that many spares and repairs. That's interesting. Surprised by that. Okay, the last question about materials that we're using. Okay, let's take a look. Wow, a lot of aluminum and stainless. Okay, anybody surprised by any of those results, analysts?
A lot of nickel base.
Yeah, great to see the amount of aluminums used on there.
Yeah, right.
Why would you say that, Bender?
I just like aluminum.
Yeah, okay. Makes sense.
Interesting. All right, terrific. Well, thanks everybody for taking the time to answer the poll questions. Without further ado, we'll launch into our panel discussion. So the first question for our session today is directed to you, Stacy, and then we'll run through, see if anybody else has other comments. But in terms of supply chain resiliency, which everybody seems to be talking about these days, it's a considerable challenge, it seems, throughout most, if not all, industries. Tell us a little bit about, from your perspective, Stacy, where you see AM playing a role in alleviating some of these supply chain challenges, and then where you see AM playing maybe a larger role down the road in terms of supply chain, and why scalability is important to this topic.
Right. I'd say right now, the area where we would see, or we do see specifically metal printing used with the spares, is in some of the lower risk parts. So validation is always an issue when you get to something like spares that have been developed and validated with the different manufacturing process. So when you go to something like additive and it has been validated with that, you need to do like the failure mode effect analysis and just go with some of the lower risk items. So that's why you might see more brackets or you know, just some plugs or something that like that you might be saying, why in the world are we printing that? We can make it another way. The reason why we're printing it is because when you get to spares and availability is a problem, it makes sense to print something just because that's the only way you can get it. So for example, my experience in heavy duty equipment, there might be a very old machine that you're trying to support and the supplier is no longer in business, the tooling's no longer available, and you only need 2 of them. It doesn't make sense to go ahead and buy new tooling so you can make 2 parts. And so even if it's just a little, a block or not even a block, but a block with some contours or something, it might make sense to go ahead and print it, even though it might, if you're looking at thousands of them, you would make it a different way. But it also goes with the fact that that would be a lower risk part. So the validation, you don't have the same sort of detail of validation that you would go through. Now in the future, the reasons why it's important to scale is so that we don't have this issue of validation, so that we have enough experience with parts that are either validated initially with 3D or we have confirmed some of similar quality issues with other processes, so that there is more confidence to go with the more critical parts in the spare parts area.
When we're talking supply chain resiliency, is spare parts, about the meat and potatoes of the conversation, or are there other aspects to that?
Well, it could be even so. I always like to think of, I always draw this like a bell curve when I'm talking with people. It could be even when business is really good and you've got supply chain issues because you're at peak demand and your suppliers are maxed out. And if you, once again, if it's something that you're comfortable with from a quality perspective and a risk perspective, and you can kind of do the peak load, and shave that off the top and print those, where maybe you're making millions a year and your suppliers are maxed out and you want to print for that extra load. So it's not just spare parts. It could be for production, I would say, in peak demand. That is not a common thing that's happening right now, but I see that as the future.
Okay. Tim, what are you seeing at Siemens in terms of using AM for supply chain issues?
Yeah, I would say the most interesting case where this has been leveraged is with our mobility group. If you're familiar with Siemens Mobility, we make trains and trolley cars and things like that. And these trains exist all over the planet, literally. And for Siemens to be able to have a central location for inventory to support all that, it's just not feasible. So what the mobility team did was developed 8 locations around the world, installed 3D printers, developed processes and parameters for a subset of components, replacement components for the trains that could be printed on demand. This is huge. The ability to use supply chain gapping with 3D printing is phenomenal when it's applied smart. And being Siemens and the monster that we are, this is all tied in through Team Center and through the PLM and even to the service level, to where a service technician can literally look up a part number on a tablet and know if it's a print on demand or shipped from a warehouse somewhere else in the world. This starts making big differences in customer uptime, how much inventory we have to hold, and things like that. So I would say that example with Siemens Mobility is probably the most exciting we've done on their supply chain resiliency. There are other places, but I think that's a good one to mention.
How long has the mobility group been taking advantage of that?
I would say they started the project probably 5 years ago, kicked it off in the last 3 years. Currently, they've got about 800 parts available for on-demand printing. And they've done about, 10,000 parts that they've printed to date. So it's not a huge scale yet, but it's growing, and it's growing daily. And the best part about it is we drink our own Kool-Aid. We develop these tools and use them internally before we even take them out to market.
Interesting. Okay. Matthias, what are you seeing in terms of the clients that your company is working with in terms of using AM for supply chain?
Yeah, my experience are pretty similar to what Tim was mentioning. The mobility sector, especially the railway sector here in Germany and in Europe overall, is leveraging the technology pretty quick in terms of spare parts. Many of those machines or railway units are running for way over 30 years. There's many trains running for more than 40 years even, and it's a very long process to replace them with new ones, although they're not necessarily efficient anymore. But the problem is really they don't have spare parts, they don't have drawings, they have sometimes really just a part breaking off. And so far, it was really always a completely manual solution in terms of machining was actually the only solution. Investment casting, sometimes an option, but mostly just too time consuming. The time was too long, so you just brought it to a machining job shop and then machine it out of a whole block. And additive really enabled them to be much faster. So what happened at some of those companies that was very impressive is that they put a lot of effort, a lot of initial investment, which is definitely necessary, into educating and marketing the technology internally in those railway companies to make people be aware, to give them a feeling of what's possible. And what's then slowly happening is that more and more people start bombarding them with questions. Hey, we have a broken part, you can replace it. And the amazing thing that's happening then is that people start being really impressed by how fast you can then react. They're just saying, well, just send over the part, I'm scanning it, and within 2 or 3 days you can pick it up, or even faster. And doesn't matter if it's a metal part, polymer part, and so on. I mean, obviously they also have difficulties here and there in terms of qualification in some cases. If you look at the insides of trains, they have to be flame retardant because there's people in there who have to be evacuated in case in an emergency. So you have certain UL levels necessary. In metals, you first have to prove that you can achieve certain quality, but they very fast found easy parts. Sometimes something as simple as a plate, as a labeling number plate or something like that, or a cover of some kind of an electronic component that's just broken off or anything. And with additive, they were really enabled to get the train back on track, literally within days rather than within weeks as it was before. So there was definitely, I think, a very big enabler for especially this mobility sector, and I think also the heavy machinery or machine industry in general is very much benefiting.
Sure. Okay, good. Excellent. And Bender, do you have anything you want to add to that discussion?
Yeah, absolutely. So I think I would echo, everything that Matthias, Tim, and Stacy are saying. I mean, I think really the emphasis there is a lot of these parts that we're seeing with the spare parts and supply chain benefits are not typical parts you would think of with 3D printing. And really, the 3D printing market doesn't really focus a lot. They focus on the high complexity, the topology optimized shapes, right? But those aren't the needs for the supply chain benefits, right? When you need a simple part, you need a simple part, right? And 3D printing can provide huge advantages to printing these very simple parts. And then the focus of what the 3D printer offer has to shift then, right? The focus has to be on speed, cost, and accessibility.
Yeah, good feedback. And in terms of where we see maybe in the near-term future scalability playing a larger role, anybody have any comments on? Obviously in mobility it's a big factor already, but any other segments of industry where we're going to see AM start to make a bigger difference in
Yeah, I
supply
think
chain?
I, th- I
Anybody?
think the automotive industry, and I think we've all recognized that an additive, Aero and Defense funds all the initial R&D because they have those budgets, but we wait for automotive to turn things into a commodity. And I think we're at that pinnacle to where automotive is looking at additive and saying, wow, binder jet in particular, they can do mass quantities of aluminum components. And with the switch to electric vehicles, I think it's been even more important. The lack of tooling needed, the long lead times, shorter model years, as I understand, are having a huge impact on automotive companies looking at additive for scalability.
Good. Okay, let's move to our next topic. Specifically, success in scaling metal AM. Maybe Tim, you can kind of get us started. Where at Siemens have you had success in scaling metal additive, and talk maybe some of the hurdles that you've had to clear to get there.
Sure. I think one of the best examples would be within Siemens Energy and replacement components for gas turbine engines. New components are great, but at the end of the day, the sale of new gas turbine engines for energy production, it's just not what it once was. With the alternative energies that people want to go to in renewables, gas turbine engines, whether it be steam or fuel driven, aren't the market's not what it was. So Siemens Energy looked at this and said, how can they produce support spares, spare parts, replacement parts, utilizing additive? And the first place they went to, and you may have seen this in media, is a burner tip. It's a really tall part. There's, I don't know, 26 of them that go into a gas turbine engine. Traditionally, it was 13 machine components with 18 welds. And the biggest thing was a 26-week lead time. And today it's printed as a single part with a 3-week lead time. Now, these parts are massive. They're expensive. So imagine trying to maintain that type of inventory and the cost of that inventory. Now, today in Finspång, Sweden, they have dozens of machines printing these. I think there are something like 10 machines that print nothing but these tall burners 24/7. But we even got smarter with that. Do we need to print the whole thing? So there was a development to machine away the burn area of the burner tip and work with the powder bed fusion manufacturer to build a machine to allow us to just print the top. So just the replacement of that. So now we're not even replacing the entire, 5-kilo part. We're just, machining the top of it off and redoing it. So additive, while it was there to solve the problem of supply chain and cost and inventory, it also enabled thinking outside of the box, as we're seeing in the additive market. And that's definitely an exciting story. On the same hand, trying to go to scalable production of some of the larger metal additive parts is a bigger challenge. We have quite a few projects within our facility in Charlotte now that we're investigating. How do we print large metal components that have, 18-month lead times? And then once they do get in, they've got another 6 months of machining and fabrication. And we're saying, okay, and Stacy, I'm sure that at CAT, you went through the same path. Materials are a little different, but it's the same thing. Is it viable to print large components? And I think today there are a few technologies or modalities in additive that are enablers for that. It's just going to take time, just like everything else. Powder bed fusion was fortunate that some of the big players took the time to qualify materials and processes. That's now enabled a lot of people to use it. Now we talk about WAM or DED powder or MELD or some of the cold spray systems. We have to qualify all that before we can get to production with those.
Interesting. Okay. And in terms of what can you say about kind of marrying all the, connecting all the different processes that go through the additive from the beginning to end? The software is post-processing, finishing, support
Sure.
removal, all those things that have to happen to scale.
Yeah, Siemens prides ourselves on our ability to build digital twins, so that end-to-end workflow for additive. And we've worked very hard, harder in some processes than others. Because we use powder bed fusion, we have all of those tools, whether it be topology optimization, generative design, build simulation. All of those tools, are available today, and as we grow, we're bringing more modalities into that mix. I think one of the biggest things that we've brought to the table that people may not have realized is on these supply chain issues. Everyone does a really good job at the front end of the office, understanding orders and when they're coming, but nobody's connecting to the equipment on the floor to say, is the pump feeding the pipe well enough to maintain this? So we've been working very hard on connecting machines, giving manufacturing teams better visibility on what they're doing, how well they're doing it, what's the quality, and trying to complete this digital thread.
Sure. Good. Matthias, any experience with your clients in terms of scaling and ensuring process repeatability? I think is a key topic too as you're scaling.
Yeah, I think my experience is mostly based on medical and aerospace or civil aircraft sector. And my experience is every industry does it differently, and to some extent, in the end, again, the same way. So it's quite interesting because just as an example, if you want to scale up, you have to make sure that the second machine, the third machine is doing the same thing as the first. So, and the funny thing is that for the medical sector, for example, it's sometimes quite easy because you just need to prove your end product is delivering the right quality. So you have not such a difficult job to prove that. But if you want to make sure in aviation you can produce parts for a flying part or even a critical flying part and a fatigue loaded part, for example, you have to make sure and you have to prove that the whole process chain is under your control. And this is something totally different in medical, which makes it much more difficult to scale up in aerospace, because in many cases they are arguing between qualifying just components versus qualifying process. If you qualify process, you really have to understand the whole process chain. If you just qualify a component, you just have to prove the component is complying with the requirements. And this is a big problem if you really want to scale up, because you have to make sure that the next machines you have are doing the same thing. And what's happening here is that the additive sector, the additive machine builders are still heavily innovative. And if you buy, after 1 year, if you buy a second or third machine, it's most likely completely different from the first one you bought. So interesting thing is, if you, for example, are a medical supplier and you bought, let's say, an Arca machine, a Q10 in the beginning, and now you want to scale up, you want a second or third Q10 with the same properties. And that was actually having an impact on the whole Arca universe, because they focused very much on remaining the Q10 as it was, because a large segment of their customers demanded this machine, although it was not the most efficient one. There was definitely room for improvement, but customers qualified that. They wanted the same machine. That's quite interesting, because machines are really evolving. If you look at other high-profile customers like GE, Siemens, I'm sure had the same experience. They've qualified a certain machine. Let's look at the fuel nozzle, for example. I'm very sure it's a single laser machine where they qualified it on, and now the technology is much more advanced. So they're not even using all the advantages the technology can give currently, because they're, let's say, stuck in their qualification framework, which they can't leave, and which is very expensive to leave or to switch in layer. So what we have there is a very weird situation that actually we all want additive to evolve, companies to innovate and bring out faster machines and so on. At the same time, the established customers want the machines to just stay exactly the same and just ask for reliability, ask for machines that are the same but run more reliable. So it's a very interesting and tight spot where the machine suppliers are in right now.
Yeah. Yeah. So Bender, in terms of machine qualification, what are you seeing in terms of the hurdles that creates to scalability, and is there a relatively simple path to overcoming those machine qualification hurdles?
Yeah, absolutely. So I agree with Mateus completely, and I actually recently had a discussion with some of the groups that are working on the qualifications, and they were saying that the actual qualification entities, specifically if we focus on aerospace for a second, right, they have to evolve to adapt to the pace of technology evolution on the AM side, because all the traditional ways of qualifying in aerospace are based off of manufacturing processes that don't evolve and don't have the same level of complexities along the chain that additive has. And if you think about that, so if we break it down for a second, with additive, you have to, as Mateus was saying, qualify the complete process. And it's really not just the hardware. The hardware is only one piece. You have the software component, which you also have to stabilize, qualify, and configuration management is a huge aspect of that. How are you controlling that configuration management? And then the biggest piece is that material piece, right? So how are you qualifying and controlling that supply chain of material? And with a lot of additive manufacturing processes, they have certain formulations of material that are specific to their process, which means that they have to take ownership of ensuring that whole supply chain. And that's a huge challenge. And so I think additive companies right now are working with industry and also working with certification bodies to say, how do we improve this from the qualification side? And also, how do we improve this from the technology side such that we add more sensors, add more process monitoring, add more process learning through AI so that we could speed up some of these processes. But it's still a big challenge to try to overcome that gap.
Yeah, good. Stacy, how about from your perspective, scalability versus maybe outsourcing if companies aren't ready to quite jump in and commit to scaling? What do you see from the folks that you work with?
I'm shaking my head a lot, just especially with when Matthias talked about, you buy something and then you have to stay with that model of machine, even though there's newer ones available because of the qualification. And I would say, the qualification is just, we're gonna have to learn how to deal with it. I started my career qualifying, injection molding machines that we purchased, and those aren't, new or evolving at the pace that a 3D printer still is. So the qualification is not going to go away. But if you think about what you talked about, Brad, with do you outsource or do you buy? And I think whenever a company, the clients I work with, even my experience at Caterpillar, it's like, we need to go buy something. We want to go buy something. We want to buy a machine. And there's just so much work that can be done to be sure what machine do you buy. Just even in the survey we did at the beginning about the different technologies people were using, and it was kind of mixed between the ones that we had listed there. But within those technologies, there's a plethora of different, details of the types of not only the technology, but then the machine you get. And I think to spend some time working with a supplier, do your due diligence, do some visits, have them print test parts or whatever, to work with a supplier before you jump in to try to buy machines yourself. And I'm talking about like an end user that would be doing it, not somebody obviously that's maybe a service bureau or a production partner, but to do that, and then maybe you just have a better chance of getting the right machine, even if it's still going to be updated and you're going to have to stay at version 4, even though version 8's out there now or something. I think it's like, do the time with the suppliers that are out there that really know their stuff, and they're out there, and give them the business, work with them as partners. And I don't see that happening as much, because I think people get excited about wanting to get in and they have got money to spend, and let's spend the money and buy some machines and that sort of thing.
Right. All right, good. Anybody else want to chime in on this topic before we
go to our next question? Could, I find this topic is really interesting to Siemens. As we all know, additive is a forging machine and an end product, a net product, which makes it different than traditional manufacturing. We buy certified materials and then we just transform them into a finished product. So what we've been doing at Siemens is trying to figure out, how do we build an automation system to allow the machine to export a digital twin, not just the actual part, but a digital twin of what the machine did versus what you wanted it to do. So if you could build a digital twin with all your simulations and all your material properties based on process, input that into the machine, and when the machine is done, it also spit out a digital twin. Well, now you have a validation certificate, and it's far-reaching. It's not there. We've started an ICME digital twin project within Siemens to try to understand how can we do this. We can't continue to qualify everything the way we've been doing it. Matthias, you brought up the fuel circuit with GE. I was with Morris Technologies when we developed that. There was 10 years of development just in the cobalt chrome, the material, let alone the process. So we've got to get away from that. We've got to get smarter, and we've got to learn how to leverage the digital tools we have at our disposal.
Thanks, Tim. Yeah, really good input there. All right, so we'll move on to the next question. We've got about 20 minutes left or so. So Matthias, let's talk about some of the metal AM processes in terms of scalability. Are you seeing more scalability in the liquid metal side or in the laser powder bed? Where are you seeing that today, and where do you see that evolving with the different metal AM processes?
That's an interesting point, actually. I think scalability in many cases still has the challenge of cost. I mean, clearly in many cases, additive just makes sense because you have low volumes. That's just in many cases the case. Of course, you have products that are better, higher performance, reduction of components and so on. But in many cases, AM applications are still considered considerably low volume parts. And the interesting thing is many of the new technologies that are currently coming up, and I mean we have many new technologies. Almost every month there's something new coming, if not even faster. It's really hard to keep track of that. I think on our map we have on our two maps for polymer and metal, not even including concrete or other materials, bioprinting or anything. Just on metal and polymer, I think we have over 30 different technologies in this map, and it's really hard to keep track of it. But most of the new technologies are trying to focus on high volume, on scalability, and all those let's say buzzwords, reducing cost of the parts and so on. And the interesting thing is, of course, not all of them really match that description, but there are really some technologies. I would say binder jetting is probably the most prominent one that actually only makes sense in the scalability content, because binder jetting by itself is such a complex technology. I consider it to be more complex than laser powder bed, because of the many links and the many sections you have, the many processes you have in between. I'd say it's more difficult to really qualify. So you have to put much more development efforts and actually into applications, which makes it very unsuitable for low volume production or one-offs or a mixture of many different parts in one build job. That's just not the right technology for it. It's really a technology that you only use if you want to produce 10,000 and more parts, at least for the more complex parts. So it is a technology that's completely designed for scalability, actually, and it's designed for scalable production. It's still far away from that, to be quite honest. The technology still has a lot of issues to solve, but it is clearly designed for that. Completely different, of course, with technologies that are designed for spare parts. I mean, Bender, you mentioned it. The Xeris technology is the ideal technology for one-offs because you have an extremely fast process chain. You basically hit print, you get the part, you take it off. You don't even need to wire it off or anything. Not much post-processing, and you have a part in your hands. And that's obviously a completely different technology that's designed not for high volumes and scalability to that extent, right?
Yeah, Bender, you want to comment maybe a little bit about scalability with the liquid metal process?
Yeah, absolutely. And so, yeah, I agree. I mean, if you look at some of the processes out there, and it depends on really when you're talking about scalability, are you talking about scalability in terms of having one system produce a lot of parts, right? Then I agree with Matthias 100%, right? You're looking more on the binder jetting side, right? But if you're looking at distributed manufacturing, right, and adding in printers at a number of different locations, now you want to look at how lightweight of a process can you have, right? How can you put access and how can you enable access at many, many different locations to this technology, and how can you reduce the barrier to learning how to use the technology and the barrier to adoption as much as possible? And also, how can you create just a lightweight facility, right? And that's where you look at technologies like the Xerox liquid metal printing technology using off-the-shelf aluminum wire. It's a very simple process, and that lends itself to ease of use. It lends itself to the ability to have many printers at distributed locations that can produce these one-offs when needed, which really helps that supply chain resiliency story.
Excellent. Stacy, I know we talk about scalability and in terms of early and late stage. Talk a little bit about what you're seeing with your clients that you work with in terms of early and late stage scalability.
I think it's about more of the ramping up. So there's not just oh, we got an application, looks great, and boom, we're going to go to thousands a year. What I have seen is that it'll usually go on one product line, so or one product period, maybe one model within a product. And so, prove it out on that, get the kinks worked out, get everything we're talking about with the different steps of the process. And it might be fairly low volume, but it's a good application. So that could be a scale up. It's in production, you're making several parts, it's all good, but then you start to expand it across the product line and get the same application but different sizes and maybe a little bit different hole pattern or something like that. And so I that first step up to that first model number, that could go on for a year or two in order to get all the kinks worked out and really see the value of it, and then you start ramping up more. So I always see it like steps of scalability, and haven't seen a lot go beyond that first model, that first part, just because it's hasn't been going that long in the markets I'm in with the heavy duty equipment, but then the ability to go and just keep expanding it and expanding it. So then you get I think a lot of when I hear when Tim talks about his applications that he's got with Siemens, that's sort of what the end game is, but we're just in maybe that first model kind of stage.
Right. Yeah, Tim, in terms of scalability with the liquid process or liquid metal process or any other processes at Siemens, what are you seeing there success-wise?
Yeah, I mean, we've obviously scaled with powder bed fusion for obvious reasons, mostly material and geometric. We're looking very hard at Xerox. We're having a lot of discussions with Xerox right now because we see the ability of the process to scale. We're poking them because we see their current machine and go, that's cool, but what if? So we're it's that same mentality within additive is, oh, that's awesome, but if it could do this, I go back to a story I've told often about my 8-year-old daughter. I was running Beam machines and she's standing there watching the machine, big DED system print. She comes to my office and she says, I don't get it. I said, what do you mean? She said, why aren't there 10 nozzles in there printing at one time? And I told her, I said, you're exactly right. What you don't understand are the challenges to get there. But that mentality of we look at things in the additive space and go, this is perfect. How do we scale this? And it's not always about scaling number of machines. How do we scale the process? When I look at the Xerox liquid metal, it's phenomenal. Material properties are great. Speed is great. How do we scale that process? Not to mention more materials.
Yeah. Bender, you're nodding your head. Do you have any additional comment on the?
Yeah, absolutely. I mean, I think that's what's really exciting, right? I mean, I think, if you look at the metal AM landscape and to Matthias's point, right, you really kind of have a lot of technologies coming out, but then you have incumbent technologies, right? And you have the incumbent technologies like powder bed fusion that really have a lot of benefit, and they've really showed a lot of maturity. And now they're at kind of that stage where they're getting qualified, the application spaces have been identified, things have been mapped, and people are saying, okay, how do we, kind of tighten the screws on this technology and get it more production focused? With us, we're a little bit earlier on that journey, right? Where this technology is actually relatively new, even when, outside of Xerox, just in terms of a technology standpoint of view, it's kind of got its own segment, right? The liquid metal printing. And so that's where we're kind of at the ramp up phase where we're saying, okay, well, what materials can we add to the technology? How do we evolve these technologies? And how do we leverage the inherent value in this technology and optimize it for its most potential?
Excellent. All right, good, thank you. So that takes us to the end of the session here that we had planned. We'll open it up to questions from our audience. We got about 10 minutes left for Q&A. So if anybody has any questions for our esteemed panel, go ahead and fire away using that question panel. So I'll go first and ask Bender, in terms of the LMX process that we've talked about a little bit already, why aluminum particularly, and where do you see the opportunities for the process with aluminum?
Yeah, absolutely. I think when you look at the metal AM landscape, and that's why I was actually very excited to see the poll where it's such a high percentage of aluminum, which is interesting because if you look at kind of a lot of the powder-based systems, although aluminum is common, right? A huge focus is on the higher performance, right? A huge focus is on your Inconels, your stainless steels, right? The very high performance materials for high performance applications. And we see a huge opportunity in the aluminum space, because the aluminum space, that's where you are getting to Stacy's comment of the lower risk applications, right? Those are your simpler geometries. But there's a challenge there. Aluminum powders are very difficult to deal with, right? And aluminum powders are difficult to maintain from a facility standpoint of view. So that's why we see coming in with a wire solution is having a lot of advantages, because you have a lot of adopters in the AM space that want to get their feet wet with AM technologies, but are scared of the hurdles that dealing with powder face. And that's where we think a big opportunity is to come in with a wire-based solution that can help them in their ease of adoption, where they could start to say, oh, I could consider this, I could now consider 3D printing, right? It's a little bit of a different focus, where you could go into a facility that knows how to use powders very well. They're like, no, we know how to handle it, right? That's a different target. We're starting to target, how do we expand out the user base for AM to go after those people that have been skittish and shy to really adopt the aluminum powders and powder-based technologies.
Yeah, I mean, even companies who know how to deal with powder, the EH&S requirements for aluminum powder are not the same.
Yeah, absolutely.
Matthias or Stacy, you've seen that as well, with maybe the adoption of wire process, liquid metal in this case, versus powder?
Yes, definitely. There's hazards with powder, and you have to know how to do it. And there are concerns, especially with aluminum powder, and there's thermal events, and yeah, right. Dealing with a wire is definitely eliminates so many of just the EH&S issues alone, let alone some of the other benefits that would come that way. So, no doubt.
Yeah, nobody likes
powder. Nobody likes powder. Okay. All right, next question is for Matthias. In the automotive industry in particular, which metal 3D printing technologies do you think will make the most impact for low volume production, as well as for aftermarket parts, which is a big part of the discussion of automotive?
That's an interesting question. So I guess we're talking about end use automotive applications, because right now the largest market share of applications in automotive are not actually car parts. They are tools and they are jigs, fixtures, and so on. That's a huge segment and a huge application group, and prototyping as well. You have no idea how big the automotive market globally is actually versus many others, and they have an incredible amount of prototyping, not even utilizing completely 3D printing. So and they use obviously all technologies that are out there. But if we look at low volume parts, end parts in sports cars, high-end vehicles, luxury cars, maybe. I mean, there's some progress in laser powder bed. I mean, BMW is doing a pretty good job at it and having some applications out there. The big money maker is not, it has not yet been seen. It's just too expensive. And as soon as you can simplify the design just a little bit and drop the cost, cut the cost by half by just using a tooling process, you just do it because it just makes sense in most cases. Or you use components from high volume cars and just adapt them and change them a little bit for the low volume series. The cost pressure is just too strong in so many automotive segments, except maybe those very few low volume sports cars that we see out there that sometimes really have impressive applications. But like I said, those are not cars that you can buy with at $100,000.
We've seen a lot of polymer applications that are going to production, but they're typically complex components.
Mhm.
Yeah, and again, it's something that is maybe politically driven in some cases, but in many cases, I've seen applications really drop out in the end because the injection molding guy just came around and said, hey, I can do that almost the same design, but at half the cost. And suddenly, the interesting thing is what I've seen many times in convention industries is actually that convention technology suddenly come around, get innovative, and casting or injection molding companies suddenly become very flexible and enabling designs that are previously being designed for additive, and they just say, yeah, I can do the same thing, maybe with a few changes in the design, but we can do it at much lower cost. So that can be quite challenging. I mean, but if we look at more on the future scale, obviously binder jetting has a very big potential in automotive, especially with their aluminum progress. Ricoh just published their aluminum process for binder jetting. Desktop Metal has announced it a couple of months ago. X1 published something. Clearly, it's still at a very early maturity, maybe 10 years behind laser powder bed, I would say, until we are at the same level. But it's obviously it's possible, it's technically feasible to print aluminum and to sinter aluminum in binder jetting, and the technology itself has just much higher scalability potential because the print process is decoupled from the actually melting process, which gives you an enormous speed advantage, which you can increase dramatically. And this in metal, at least, this is the highest potential. And looking at polymer, obviously the technology that we've seen around HP and is also one that is much more scalable than laser right now, at least until we've seen the EOS system or the newer multi-laser systems for polymer coming up, but they're still a bit a bit further out until we see something there.
Sounds good. We talked about the whole process chain for additive in terms of scalability, from design through finishing. Where does inspection, quality, X-ray and CT inspection, for example, fit, and how does that, let's say, improvements in those technologies help with scalability of metal additive? Anybody want to jump in on that one? X-ray and CT inspection in particular.
Yeah, I will.
Scalability.
I think it fits into that whole chain. I can't remember if it was Tim was talking about it, like all the steps in the process. It's not just about printing. And I think as we scale more and more and more, you get more experience with that. You've got more data points. So maybe you can pull some of those processes out as you see that, if you're doing your process control and, we don't even need to take this data point anymore. So I think we start out with some of those, especially with the CT or 100% inspection and the X-ray. And then as the processes evolve and continue to get more and more reliable, that we pull those back out. But right now they're there in some particular applications, not all, depending on the complexity. But yeah, I think the end game is that you start to back those out as you see they're not needed.
I think it's interesting how how many players are out there now for CT.
Yeah.
It's like they came out of the woodwork once the first one really said, hey, this is viable for additive, and now there's a dozen of them. And I think that's actually good because it's forced them to build faster systems with higher resolution and bigger volumes. You want the finest resolution, you'd only get it on a tiny spot, but they're all working to increase that. And I think that's valuable to the AM industry as a whole.
All right, good. Anybody else have any other questions for our panel? We've got a couple minutes left. For Tim, what's the typical facility cost? That is a tough question to implement laser powder bed, whether it's a single or a multiple machine. Typical facility cost.
Yeah, that's a loaded question.
Yeah, I want to hear that one too, Tim.
Yeah, good luck. I can tell you what we can do is we have tools to build virtual factories to help you figure out that cost. The cost is different for everybody. We all know that a powder bed fusion machine can be $500,000 or $4 million. It depends on how big you go. But then putting it in the facility and maintaining powder and the process, the pre and post, there's just so much there. What Siemens has done is focused on some tools to allow you to build virtual factories for production settings, so you understand what those costs are and how many machines do you need on the floor, how many people do you need on the floor, et cetera.
Okay, yeah, recognize that's a tough question. Stacy, we talked a little bit about the outsourcing conversation versus bringing in more equipment and trying to scale up. If a facility will not allow for certain technologies, maybe they're too hazardous. We talked about powder handling. Does it make sense in many cases, or let's say in which cases does it make sense to bring in equipment to satisfy a company's particular innovation needs versus outsourcing to a third party?
Right. Normally, I would say if you have something that's really innovative, you want to keep that in-house and outsource the stuff that's more of a commodity. That would be like my normal response. And, I've kind of gone back and forth on how I feel about that. And then you come to, 3D printing. Anything 3D printing is not what I would call a commodity. So you would want to keep that close to your vest, which would mean printing yourself. However, because of this rapid change of the technology, I think there is something to be gained, like I said earlier, about working with the people. And then if it's like super, super secret, then you almost have to, maybe partner with them or figure out a way to bridge that quick evolution of processes and technology that I know in my case and in my client's case, nobody's used to that. So I still think that partnering is, and then based on what the application is, really make the evaluation of, okay, we do have this super secret thing or this great innovation that we're going to put out in somebody else's hands, and are we okay with that? And is it worth doing that versus going through a lot more maybe trial and tribulation and trial and error if we do it in-house?
Excellent. Anybody else have any feedback on that question before we wrap things up?
Yeah, I have a quick thought on that as well. I think I agree with Stacy, and I think also from a technology standpoint of view, a lot of that decision drives from process expertise, right? And a lot of the technology right now, I think you could go to any service bureau and they're going to advertise how they are specialists in that process, right? So I think the question should be asked is, how do we take that out of the equation, right? Because that's a barrier to adoption. If you have to continually have that be as a trade and as a special sauce that certain experts are using, right, that's going to limit your scalability of that technology. The more you can make it user-friendly, easy training, you can send it anywhere and everybody gets the same part, that's a key to scalability.
Yeah, the mindset is to use software for that solution. However, we all know that there's so much tribal knowledge in additive that we just can't get out of people's heads and into software packages.
Yeah, great comment. Excellent. Okay, good. Well, we've kind of reached the top of the hour here. I don't see any more questions from our audience. So I will take this time to thank our panelists for really an engaging conversation, and again, thank our audience for attending today. We certainly hope everybody found it to be a valuable experience. Again, I want to remind you as well that an archive or recording of the program will be available on our website either later today or tomorrow. We'll send out an email when it is ready for you to review what you learned today, and then you can share the archive recording with others in your organization. So again, thanks to our panelists, thanks to our audience for attending. You can close your browsers now and have a great afternoon. Thanks, everybody.
Thank
Thanks,
you.
everyone.
Thank you.